Hello and welcome back. My name is Dan Oak and I'm a student at Athabasca University, currently taking the Computer Science 444 Embedded Robotic Programming course. And if you watched my last video, you're a patient person because it was over an hour long. But basically what it did was I talked about the nRF24L01 wireless data transmission module. And I went through a couple of the tutorials that you can find online, but I went through them in a little more detail, just highlighting some specific aspects of the tutorials and showed you the completed project of mine after following the tutorial. So I said in the previous video, just a quick recap, the reason we use this module, it's a great little thing if you want to add some wireless capabilities to your microcontroller projects. And you can do that with wireless modules, so Wi-Fi modules. The problem with them is they consume a lot of power and there's some latency when they're first hooking up to Wi-Fi networks. The advantage of the RF transceivers is you can still have wireless capabilities, but they have low power consumption. So 22 microamps when in standby mode, something like 900 nanoamps when in power down mode, so like, very, very low power. And even in operation, there are 12 milliamps operating power, which is less than, running a single LED. So extremely low power, which makes them suitable for battery operated projects where you want to have Wi-Fi capability and use battery packs to power your controller, so you don't have to be tethered to computer. Not so easy to do with Wi-Fi modules because they are consuming a lot of power, so you're going to go through a lot of batteries. So that's kind of why we were using them. And again, I explained that they come in different modules, which basically just from internal antennae to an external antenna, which basically allows just for larger range, from about 100 meters theoretically to a kilometer. I showed that you could Google and get lots of great resources out there. From How to Mechatronics has a great tutorial, video, and website associated with them. Same with Autodesk Instructables, and as well as there's one other one that kind of talks about some different information on the module and does some different coding that isn't available in the other two tutorials. But specifically in the last video, I went through the Autodesk Instructables tutorial, can't talk, in a lot of detail, and just basically highlighted some aspects and then showed you my own completed project below. So in the previous video, we've seen that I had set up a breadboard here with two Arduino Nanos, and each of them is hooked up to one of the RF transceiver modules, so with the internal antenna. And this one is hooked up through a socket adapter, which I mentioned in the last video, which really doesn't do anything. It just makes things a little neater. And we were just transmitting code, text, back and forth between the modules. So, and then that's a little summary. So we had got into that point where we were transmitting code back and forth. And so the code I had set up was, correction, let me just get that code back up here. So the code we had set up in the previous example, we had transmitter code, which is basically sending the string hello world, to the receiver code, which was the Arduino set up on the right side, which was receiving that. As we can see, it's still working every second. So 1, 2, 3, and so forth. It's receiving hello world. And that is, again, happening right here. And I can unplug this, and I'm going to use an external power source, which I did in the previous video, and we can see that communication has stopped. We stopped at 200. We stopped right here, the timestamp. But we can see when I hook it up again to an external power source, we start transmitting again. So you can see that this module truly is being, the data is being transferred wirelessly to this module, because there's no connection from this Arduino Nano and the module to the computer because it's being powered by an external power source. So I'll unplug that. So that was the previous video. Quick recap for you. Hopefully quicker. And so that's what we're doing. So this code's essentially transmitted just text. That's all we were doing. Nothing too amazing. However, I did mention that there was a joystick hooked up to the transmitter and a servo motor hooked up to the receiver, but we weren't using in the previous example. But we will be using in this example. So I'm just going to get rid of this code. And now in this code it's very similar, but this one is transmitting the joystick X value. I'm only dealing with the X value in this. I've got I'll just pull it up here. I've got both on the joystick. The pins for the joystick are ground, 5 volts, VRX, VRY, and switch. Switch is if you push down on the thing. I've got this switch wire, which is green, not hooked to anything. It's just dangling out here. I'm not using it. And I did plug in both the VRX and VRY, so the signals for the X-axis movement and the Y-axis movement, to the nano. But I'm only using the X for this code. So just keep that in mind. I'm not using the Y at all, hence why it's transmitting joystick X value. And in the receiver code, I'm just going to take that X value and map it to a position from 0 to 180 for a servo motor. So I'm just going to go through this code. We can clear this. So that's still transmitting hello world because right now the other code is still on there, but we'll update this here in just a second. So actually, I'll just take that away so it doesn't distract us. So for the transmitter code and the receiver code, as before, we're going to include certain libraries with both codes, the SPI library as well as the library specific to the module itself and the nRF24 library, which again you can find by just Googling nRF24 library and getting it off GitHub, or you can just get it from the using the library manager in the Arduino IDE directly. So you're going to do that both for the transmitter and receiver code. You're also then going to create an instance of your RF24 object. Just call it radio by convention. And you're going to pass in 2 arguments, 2 ints representing the CE pin and the CSN pin. That's the chip enable pin and the chip select not pin. If you're not familiar with what those are, feel free to watch the previous video if you have some time. And so I've made them the same pins on both. That doesn't really matter. The CE and CSN pin can be any digital pins, just so long as you make sure you hook it up properly in the breadboard. I've used pins 9 and 8 for the CE and CSN pin respectively, both on the receiver and transmitter. Then you need to create an address, which is just a one-dimensional array of type byte that you're just making some arbitrary address. This could be really any 5-letter string at this point. The only importance is that the transmitter and receiver have the same address. In setup, we did this all in the previous video. We go radio.begin. We call the begin function. This is kind of how a lot of libraries allow use of their modules, of their sensors and things. Is you have a begin function. So we've set up the radio to communicate. When we're using the module as a transmitter, we call the open writing pipe function and pass in the address, the 0001 here, as the argument. So the open writing pipe specifies it's going to be a transmitter. On the receiver side, we open the reading pipe and we pass in 2 parameter arguments. The first one 0 and the second one address. You can look into why that's 0, or you can make it 1 as well, or you can click on it and get the IDE to tell you why. But really, just for now, just put a 0 or 1 in there and you'll be fine. If you want to look more into that, you can. But the address, again, has to be the same as the address for the transmitter. You're going to set the PA level. You can go radio.setPA level, which is the power amplification level. It's how much power the module's getting, either from the microcontroller directly or an external power source. I've set mine with a constant RF24_PA_min. because the modules are right next to each other on my desk, so I don't need much power amplification. The transmission will likely go through. If you were doing this and you had an experiment where you had a fair bit of distance between your modules and you want to ensure that you are transmitting without losing signal, you might want to change that min to max and get the full range capability. It's just going to draw a little more power, obviously, from your microcontroller or external power source, but that's just going to depend on your application. For the transmission, you're going to go call the stop listening function, which sets the Arduino and the module as a transmitter, indicated by stop listening. You're not listening for anything, you're just transmitting. The opposite is true on the receiver, where you're going to start listening, therefore setting up your Arduino and module as a receiver. In the loop function, you're going to read, in the loop function now, instead of sending text, we're going to use an analog read of A6 pin. So I'm just looking here. So I've got, so again, on the transmitter, the Arduino here on the left, which I have set up as a transmitter, again, I'm only concerned with the orange wire, which is set up on my VRX, so my x-axis movement. So that is in pin, probably can't see it there, but it is analog pin 6, whereas the other one is in analog pin 7. So A6 for the x-axis, A7 for the y-axis, but I'm only concerning myself with the x-axis for this example. So do an analog read and get that put that value into a variable of type int called pod value x, and then I'm going to map that pod value, which again the analog read reads in a value from 0 to 1023 because the Arduino has 10-bit resolution, so 2 to the 10th power is 1024 different values, which translates from 0 to 1023. So that's what I'm going to read on my analog pin, but my servo motor that I want to control has an angle between 0 and 180. So I need to map my 1023, my range of 0 to 1023, to a range of 0 to 180. So I'm using the map function and then assigning that value to angle value. I could have also just divided I could have done an analog read and directly divided by 4 and put that directly into an analog value. That'd be fine. 1024 divided by 4 is roughly, will give us the value between 0 and 256, which is what the value we want to send out. But then as I'm saying this, I'm realizing that's if I wanted a value of 0 to 256, is if I was sending out an analog pulse with modulation to light an LED or something. But you know what, that doesn't apply to this because I need this between 0 and 180 for a servo. So just ignore what I just said. We need to use the map function to keep the math simple and just map the pod value that we're going to read off the analog read from 0 to 1023 range to 0 to 180. So if you're not thoroughly confused, I'm going to move on. So we're going to call the radio.write function, just as we did in the previous example, and we're going to, the first parameter argument is going to be a reference to the variable angle value, which is the thing we just mapped. That's going to be a value between 0 and 180 depending on our analog read from pin A6. And then we're going to send what's the size of that analog value. So it's an int, so it'll be like 4 bytes. So we're going to send that, transmit that via the module, and we're going to have a delay of 15 milliseconds. And that's just to allow for things to be read properly, because the servo motor, if we're sending it too quick, the servo motor needs physical time to move to position. So we just have that delay of 15 seconds. On the receiver side, again, we started listening, so we're a receiver. So in the loop, we're going to go if radio.available. And again, that's just like if we were doing serial communication, we'd go if serial.available. Basically, if radio.available just lets us know, hey, is there any data being transmitted to us? If there is, great. We're going to go in here and we're going to create a variable for the angle V. And then we're going to use the radio.read function to read in the data that we get into angle V, and again, the ampersand indicates that this is a reference. We're actually going to read the value into this variable. And the size of, again, we have to include the size of the data that we're going to read. And then we're going to serial print that to the serial monitor. So let's open that up. So I'm going to upload these directly. So this is on COM, the transmitter is on COM 11. Setup is, the board is a nano. So I'm just going to upload that. So we should see this hello world stop momentarily and freeze. Yeah, see, we stopped there. Now we just got this weird W being transmitted, I guess. And that's because I'm no longer transmitting hello world. So now I'm going to upload this. It's on COM port 21, nano. Uploading. So now we're done uploading, and I'm printing out the value of the angle that I'm expecting to be at, and it's 87, which makes sense because it should be between 0 and 180, and because I'm not touching it, it's in the middle value, which is 87. I mean, 90 would be, you know, halfway between 0 and 180, but again, these analog joysticks are from, you know, the 37-in-1 sensors, so you know they're not the best. Obviously, you get what you pay for. But anyway, so as I move the joystick, I should be moving the servo motor, and there seems to be something off here. Okay, so if I move the joystick, I'm getting 0. And I'm getting 180 values, but this servo's not moving, so let's look. Okay, so I guess I'm just at this point, I forgot to actually do anything with the servo motor. I'm just sending the value of the angle to serial print. So I obviously am transmitting the value from the transmitter to the receiver, because I'm transmitting 87 when I'm not touching, and when I'm touching the joystick all the way to the 0 index on the x-axis, I get 0, and all the way to the right, I get 180. So I am transmitting the data, but I guess I'm not doing anything with it. So let us fix that. So we'll just include, it's going to be a real-time code demo now, so we're just going to include the servo library. So servo.h header file. We're going to create an object of type servo. We'll call it my servo. In setup, we will create my servo. We're going to call the my servo.attach function, which is essentially pin mode. Instead of calling pin mode and setting up the servo as an output pin, you just call the attach function and pass in the pin that it's on, which is the signal wire of the servo is attached to digital pin 5. So we'll put 5 in there. And down here, we can still read it in, that's fine. But then we're going to go my servo.write, and we'll just write the angle V. I should have needed a delay because I'm getting a delay from the other end. So I'm just going to leave it without a delay for now. That should be fine. And let's see if that works. So this wasn't meant to be a live code demo, but I obviously neglected to have code that actually moved the servo. So hopefully this gets us going here in a minute. Okay. So there is delay. So as you can see, I'm pressing, and there seems to be quite a bit of delay. So I'm just going to add a slight delay on the side, so when I move the servo motor to the angle, there's a delay on this side to actually allow the servo motor to physically get there. I have the delay on the transmission side, but this should work better. Okay, so now that it's done uploading, let's just cancel this up for a second. Delay on that side. This should be fine. Let's upload this again. So I'm not sure why I switched the code and took away the servo, but obviously I did at some point. But now you can see we do have it working. So I'll raise this up. So I'm not outputting on the serial monitor anymore, but you can see I can put I'm pushing on the joystick all the way to the left, which would be x equals 0, and I can push all the way to the right, going to the 180, keep it in the middle roughly. So there is some jittering happening here. Probably, I assume it's because I do have a delay on both the code. Let's do that. You know what, let's bring this back just so we know where we're at. Okay. So I'm going all the way to the 0 position on the x-axis, back to the middle, all the way to the left, and anywhere in between there. Yeah. So there you go. So there does seem to be a little signal noise. That would be me fiddling with the delays, again giving the servo physical time to move to position and come back, and make sure there's not a lot going on that's causing any delays. Obviously I don't really need the serial write going on. I could take out some of those things, but this is showing that I am controlling the servo with the joystick, and again the y-axis does nothing. Little movement there when I do the y-axis is me not being perfectly vertical up and down, so if I take more deliberate time. But there you go. I'm going to unhook this for a second, as I did before, just to show that it is in fact wirelessly communicating. So I'm no longer hooked to a computer, I'm hooked to a portable power bank. Oh, you know what I just realized? I do need to be hooked up in this case, because so this is a good example of making sure you have your demo fully prepared before you start doing the video. It didn't work there when I unhooked, for the simple reason that I am sending data and then reading it on this side as serial. Oh, it still shouldn't matter. What am I talking about? I was thinking I was sending serial data, but no, I'm not sure why that just shut off then. Let's take a look. You know what? If you're still watching, good on you. You're going to see just live time, troubleshooting rather. Yeah. Okay, there's a lot happening, so you know what? I'm going to end this video and we'll come right back and see what's going on. Either way, seems like it's a lot of fun. Oh, I realized what's happened. My joystick controls have come undone. So I'm going to power down. That is exactly what's happened here. I'm going to power down and plug these back in. So brown is ground and black by convention, but in this particular case, and brown is ground and red is hooked up to 5 volts. Which at my advanced age and eyesight is difficult to find. Right there. And okay. Okay. I'll put this back in. Again, this is all just live troubleshooting. Feel free to stop watching and I'll put in a timestamp later of when you could come back on. But because this is meant for the course, it's good to see this stuff, I guess. Okay, so it's in ground. Just got that hooked up to 5 volts. Probably gonna unattach it. Put it on the ground on this side just so that they're all together. Make sure none of the pins on this side came out. We upload the code. Okay. So we're back. I've rehooked up the pins appropriately. So I'm going to try this again. Unplug it from the computer. Plug it into an external power supply. And as you can see, I'm no longer hooked to the computer. I am hooked to an external power supply. And so therefore, the Arduino Uno is transmitting through the nRF24L01 module wirelessly to this one. This one happens to be hooked up to the computer, but that's fine. This one isn't. So we can see that my joystick is wirelessly controlling the servo motor. So that was a lot longer demo than it should have been. Obviously, I neglected to have the code. Oh, I just realized I didn't have this up. Okay, this demo is all over the place. So, as you can see, I have the portable power supplies powering the transmitter, and I'm controlling the receiver and servo with the joystick. And as I was saying, this has been a lot longer. I neglected to have the servo code on this receiver, so we had to put that in live. And then we had some troubleshooting issues. Obviously, these DuPont cables and the way I've got this wired up are pretty flimsy for when you're moving things around. So when I went to unhook the USB cable from the computer in order to show that the wireless transmission, I unplugged the power cables and didn't realize. So, but that's all part of troubleshooting. Whenever you're dealing with live circuits, that's the great thing about Arduinos and the sort of thing is we can take code and hardware and interact with the real world through microcontrollers and circuits. However, we are dealing with the real world, so we could have the code correct, but a pin could be off or a wire could have come loose. I mean, these wires are pretty flimsy, so that's all for the demo now. I will just hook up this as well so you can see I'm completely untethered. Both things are hooked in. Both the transmitter and receiver are hooked into an external power supply. And you can see I'm still using the joystick to control the servo motor. So again, there's no strings on me. So I'll end this video here, and we will go on with another video here in a minute. If you want to watch that one, you'll see it following this. And thanks again for your patience. I'm not a YouTuber. That should be blatantly obvious by now, I guess.